So guys, welcome back to our class. Next, we have the advanced data structure. So what do we mean by advanced data structure? So, in advanced data structure, we have the heaps and priority queues. So, the priority queues is the queue data structure and the heap is the tree data structure that operates and organizes data. The priority queue is based on a queue data structure working as a queue with a priority function. The heap is a tree data structures uses for sorting data in a specific order using an algorithm. So on our past lesson, we've learned that this is a binary trees and priority queues is the data structure working. So next we have this binary heaps and heaps operation. So a binary heap is a heap data structure that takes the form of a binary tree. So binary heaps are a common way of implementing priority queues. The basic operations we will implement for our binary heaps are as follows. We have the binary heap constructor creates a new empty binary heap that insert then k adds a new item to the heap, then find minimum returns the item with the minimum key value, leaving item in the heap. So here is this is a library. So binary heap creates a new empty binary heap. Then heap that insert k adds a new item to the heap. Then find minimum returns the item with the minimum key value. We also have the tries and try operation. So a try is derived from the word retrieval. So what do we mean by retrieval? Retrieval is retrieving a data. So it is a multi-way tree data structure used for storing strings over an alphabet. It is a use to store a large amount of strings. This pattern matching can be done efficiently using try. So here is the visualization of how the try and tries operation works. So you can see it in our screen. It's for you to find out, guys. Next, we have the segment trees and range queries. So a segment tree is a data structure used to answer multiple range queries on an array efficiently. Also, it allows us to modify the array by replacing an element or an entire range of elements in logarithmic time. This blog will focus on the build and query operations on segment trees. So we have here the visualization. So here is the example of the segment trees and range trees. Next, we have the Fenwick trees binary index tree. So a Fenwick tree or binary index tree or bit is a data structure that can efficiently update values and calculate perfect sums in an array of values. So here we have this example. So every node of bit or binary index tree has an index and a value at index. So blue means the index numbers and the value green, which is the value. So in get sum, we return sum of bit tree all access stores of value. So as you can see, the research here is you have the dummy, which is on the 0 index, then 1 on 2, 3, 4, 5, 6. So as what we have learned on the previous lesson, binary trees works in a way that we have the parent node and the child. So if it is greater, then we put it on the right side. Then if it is smaller, then we put it on the left side. So that is the advanced data structure.